Okay, hello algebra students. We're doing our last section in this chapter today. We are going to be working with geometric sequences. So I'm going to share my screen and you can see the presentation. To start with, you're definitely going to want to have a piece of paper handy so you can try these problems. All right, the first problem says to simplify each expression, your answer should contain only positive exponents. This is kind of a review. And same with number 3, we're going way back. We want to find the 10th term of that arithmetic sequence. So pause the video and try these problems. Okay, welcome back. Let's give these a whirl. So this one, we have all kinds of, we have quotient property, we have power properties. Remember, if there's one on the outside, the next one on the outside, it needs to be distributed to everything inside here, including the denominator. So we're going to have 2 to the second power. We're going to have x to the negative 6 power, right? Negative 3 times 2 is negative 6. And in the denominator, we have x to the 5 times 2 would be x to the 10th power, right? This has a negative exponent. So to give it a positive exponent, I'm going to move it to the denominator. So that leaves me in the numerator just this 2 to the second power, which is 4. The denominator, I now have x to the positive 6 times the x to the 10th that was already down there. So my final answer ends up being 4 over x to the 6 plus 10, which is 16. Remember, if they have the same base and the operation is multiplication, you add the exponents. All right, on number 2, I'm going to multiply 4 times 3, which is 12. For the variables, I have x to the 5th times x to the negative 7. I'm going to add these exponents. 5 plus negative 7 is negative 2. But I need to have my answer have just positive exponents. So I'm going to write this as its reciprocal, which is going to put it underneath the 12. So it's 12 over x to the positive 2. On problem number 3, we're trying to find the 10th term. So everywhere I see an n, I'm going to replace that with 10. So I have 14 plus 10 minus 1 times 2. I'm going to keep simplifying, use my order of operations. I'm going to do the parentheses first. 10 minus 1 is 9. I have to do 9 times 2, right? I did my parentheses. Now I have to do the multiplication. So I have 14 plus 18, which would be 32. All right, let's look at our next slide. All right, it says find the next 2 numbers in each pattern. So let's see what's going on here. Grab my pen. Let's see, to go from 4 to 12, looks like I'm adding 8, but I'm not adding 8 here. So let's see if maybe I could be multiplying by something. Let's see. If I multiply by 3, 4 times 3 is 12. If I multiply 12 times 3, I get 36. Aha. So 36 times 3, I think that's 108. Let's double check here. 6 times 3 is 18. Care 1, 3 times 1, 10. And then I'm going to multiply by 3 again. Looks like that would be 324. All right, let's look at this one. To go from 200 to 100, definitely looks like cutting things in half. Looks like I'm multiplying by 1/2. Let's see, 100 to 50, yep, cutting it in half. So half of 50 would be 25. And half of 25 would be 25 halves or 12.5 or 12 halves, however you want to look at that. All right, let's look at our next slide. So you have some vocabulary, it looks like, to write down on page 195 in your journal. Geometric sequence, common ratio, and an example to add to your notes on page 195. So pause the video, write down these definitions, and copy that example into your notes on page 195. All right, we're going to be working with geometric sequences today. We've done arithmetic before. A geometric sequence is one in which the ratio between the terms is the same. In other words, you're multiplying or dividing to get the next term. And the common ratio is that number that you do multiply or divide by. All right, so this one says, find the common ratio of the sequence. So we're trying to figure out what are we multiplying by. Oop, go back, grab my pen. What are we multiplying by to get the next terms? Let's see, we're going from 80 to 20 and then 20 to 5. Let's see, it looks like I'm dividing by 4, which remember is the same as multiplying by 1/4. So 1/4 of 20 would be 5, 1/4 of 5 would be 5/4, and so forth. So our common ratio, which we use with the letter R, is 1/4. So dividing by 4 is the same as multiplying by 1/4. So we say the common ratio is 1/4. All right, let's look at the next problems. It says, determine whether each sequence is arithmetic, geometric, or neither. So on these, you're looking to see, are you multiplying to get the next term? Are you dividing to get the next term? Are you adding, subtracting, or neither? So let's see. Looks like this time, well, they're alternating, so that's kind of interesting. What do I multiply 1 by to get a -4? Am I multiplying? Yeah, it definitely looks like multiplying. These are increasing pretty quickly. So it looks to me like I'm multiplying by a -4. Let's see if it works for the next one. -4 times -4 is in fact 16. I want to make sure we know this is multiplication. I'm putting these dots in there. 16 times -4 is indeed -64. We're multiplying by the same number each time. So this would be geometric. All right, this time, not increasing very quickly. Can I multiply 3 by something? It gets 7. 7 times doesn't look like it. This looks more like I'm adding. Let's see, 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. Since it's addition to get each next term, that makes it arithmetic. All right, let's look at our last one. Some nice writing there. All right, 2 to 4. Looks like we're multiplying by 2 there. 4 to 8. Multiplying by 2, 8 to 32. Not multiplying by 2. All right, let's see if we're adding. 2 plus 2 is 4. Nope. So it doesn't look like the same number each time. So I'm going to say this one is neither, because there's nothing I can add to get the next term. There's nothing I can multiply by to get the next term. So this one would be neither. All right, so the form for the equation of a geometric sequence, this is on page 195, or how to find the nth term. The nth term formula in this case is a sub n, right? Remember we talked about those subscripted with arithmetic. A1 is your first term, R is the common ratio, and n to the -1, that's going to get us our term number. So we're going to try one of these, add this to your notes on 195, find the fifth term of the geometric sequence. All right, so let's try this one. Again, if I'm trying to find the fifth term, I'm going to replace any n that I see with 5. So a sub 5, which represents the fifth term, is equal to 2 times 3 to the 5 minus 1. All right, so I'm going to keep simplifying. Remember, we're going to deal with those exponents first. So 5 minus 1 is 4. I keep going, right? Exponents come before multiplication with order of operations. So 3 to the 4th power is 3 times 3 is 9 times 3 is 27 times 3 is 81. So our fifth term is 2 times 81, which is 162. All right, we got some extra practice again. This is number 9. Grab my pen. Maybe. All right, the next 3 terms, it looks like these must be geometric. What am I multiplying by to go from 5 to -10? Looks like I'm multiplying by a -2. See, -10 times -2 is certainly -20. So I'll multiply by -2 every time. So -40 times a -2 would give me a positive 80. If I multiply 80 times a -2, that's going to be a -160. If I multiply a -160 times a -2, That's going to get me a positive 320. All right, number 15, write an equation for the nth term and then find the sixth term. So let's see, we've got our first term. This is our A1. We need to know our common ratio. So let's see, what are we multiplying by every time? Let's see, 3 times 1 is 15. Looks like we're multiplying by 5. 15 times 5 is 75. Okay, so our R is 5. So our nth term formula would be A sub n is equal to A sub 1, 3, times R, which is 5, to the n minus 1. All right, that's our geometric term formula. Now we're trying to find the sixth term. So we're going to replace any n in the problem with a 6. So A sub 6 is 3 times 5 to the 6 minus 1, which is 3 times 5 to the 5th. Again, remember, you've got to do this exponent first, right? 5 to the 5th power is a big number, so I'm going to grab my calculator. Let's see here. 5 to the 5th power is 3,125. And then I have to multiply that by 3. So I get that the sixth term is 9,375. So you can see with these geometric series, the numbers get big in a hurry, right? Not like arithmetic. These increase at a really quick rate. All right. Next is your assignment. And I'm pretty sure this is it, but double check on Schoology. That's where I put the correct assignment. Some of these slides are kind of old and they don't necessarily follow what we're doing this year. So double check the assignment on Schoology and the agenda. If you have any questions, you can ask me, just send me an email. Okay, good luck.